Hello, this is Mrs. Brown, and today we're going to look at multiplying a polynomial by a monomial. Basically, we're combining two skills that you've already done, the distributive property and the product rule. And that's really what this is about. So multiplying a polynomial and a monomial is not super difficult if you can do the distributive property and you can use the product rule. Okay, so let's take a look at this example. Remember the distributive property, when you have something outside the parentheses, you're going to multiply each thing inside the parentheses by that, each term. So when you're looking at the coefficients, you multiply them like normal. 3 times 4 is still 12. Okay. When you look at m, remember that when you have a variable that doesn't have an exponent listed, that exponent is 1. So m to the first times m to the second is the same as m to the 1 plus 2 according to the product rule. So that would be m to the third power minus 3 times minus 3 here is going to be 9. And again, m to the first and m to the first is going to be m to the 1 plus 1, which is 2. Plus 3 times 2 is 6. So it's just 6m because there's not a variable to combine it with. So when I distribute, if I'm multiplying this monomial by this polynomial, I'm distributing 3m using my product rule when I have the same variable. So 12m to the third minus 9m squared plus 6m. Let's take a look at another example. Okay. So if I have x squared times 2y squared plus 8x. Okay. Once again, I'm going to distribute. So I'm using the distributive property to multiply the thing on the outside by each term on the inside here. And so when you're looking at this, I don't have any x's here. So the coefficient is 1. So 1 times 2 is still 2. It's x squared y squared because I don't have any x's to combine it with. So it's literally just x squared times y squared. I can't simplify it any more than that. Plus, okay, I've got x squared times 8x. So 8 times 1 is 8 because the coefficient's 1. And then this is x to the first power because I didn't list something else. So x squared times x to the first is x to the 1 plus 2, which would be x to the third. Again, my product rule says when the bases are the same and I'm multiplying, I'm adding the exponents. And so this turns into this when I'm multiply it out. Okay. Let's take a look at another example. This time with a negative number. Woo! Yeah. Not super complicated, and I'll give you the same advice that I give when I'm teaching regular old distributive property. This minus sign, the best thing you can do is make it plus a negative, because subtracting positive 3 is the same as adding a negative 3. You're way less likely to mess up the signs this way. So I'm distributing the negative 2 to each of those terms inside. And when I do that, negative 2 times 4, I multiply like normal. That's negative 8. This is going to be n to the first times n to the first. So n to the first times n to the first is the same as n to the second because I'm doing 1 plus 1 using the product rule. Plus negative 2n times negative 3 is positive 6n. Again, I don't have any n's to combine it with. This is my final answer. The number one mistake that I would see for this problem is a subtraction sign here instead. Okay. If you don't do this, understanding that negative 2n times this is going to give you positive 6. They cancel each other out. So if you treat it like plus and minus, you're way less likely to make that mistake of having a minus sign in here instead, because that would be the wrong answer. It's a totally different number. Okay. All right. If we take a look at one more problem, let's say I asked you to simplify this problem. Okay. You're going to notice I actually have two problems that are added together. So this is kind of taking the last adding polynomials thing together with your multiplying. I have to deal with the distributing first. So I'm going to distribute here and then combine like terms. So I have to start by doing the distributing. So when I look at that, negative 3 times positive 4 is negative 12. And y to the first power, because it's not listed, let me go ahead and put those in. That's the only two. Y to the first times y to the second is y to the third, because I'm doing 1 plus 2 according to the product rule. Negative 3y and positive 7y, that's negative 21. Okay, y squared, because it's y to the first times y to the first, so that's y to the 1 plus 2. Plus negative 3y plus times 5 is negative 15y. Plus, now I got to distribute this one. 2 times 8 is 16y squared. Plus 2 times 3 is 6. Okay, now that I've distributed everything, I'm looking for like terms. I've only got one thing that has a y to the third with it, so it can't be combined with anything else. So the beginning of my polynomial, if I'm writing it in standard form, would be negative 12y to the third. Okay? Now, I'm going to look for y squareds. Do I have any y squareds? Well, here's one y squared, and here's another y squared. So negative 21y squared and positive 16y squared gives me negative 5y squared. Again, I'm just combining like terms. I'm no longer using the product rule because I'm just simplifying. I'm adding. I'm not multiplying it together. Okay, so you wouldn't combine the exponents. It stays the same because I'm just adding it. Adding and subtracting is not going to affect those exponents. Okay. So then I'm looking for if I have a y by itself, and here's just a y. The only thing I haven't used is the constant, and so it can't be combined with it because I'm just adding. So this is plus negative 15y plus 6. And again, I can leave it this way, or instead of plus a negative, I could just have it as minus, also works. Okay? That's multiplying a monomial and a polynomial, and basically, again, you're just using the distributive property and your product rule when you're doing it. So making sure that you're combining those two skills. Have a great day, and if you have any questions, you know where to find me.